this right here, this muscle that you see is the cremaster muscle. The cremaster muscle is what allows the animal to pull the testicles up into the body to regulate temperature. So like this, these little squiggly lines right here are what we would consider the seminiferous tubules. So that's where spermatogenesis occurs. They house the Sertoli cells. So if you look in your book at the testicle pictures, spermatogenesis occurs in the seminiferous tubules and then empties into the rete testi, which will be a long column in the middle. No sperm formation occurs in the rete testi, it only occurs in the seminiferous tubules. But the rete testi would come up and empty into the efferent ducts. So this area right here houses the efferent ducts. Then sperm will dump into or go into the head of the epididymis. So this right here is the head of the epididymis. The head of the epididymis it's immature sperm. They can't move at this point. They do have the ability to fertilize, but they have no motility. They leave the head of the epididymis and go into the body of the epididymis right here. In this portion, this is where sperm acquire motility. And then finally they go into the tail of the epididymis, and this is where mature sperm are housed. So the time it takes to go from the head of the epididymis all the way down to the tail is about 2 to 3 months, depending on the species. But once they're here, they're mature, they can move, and they're ready to leave the testicle. And they do that via the vas deferens. So this right here is the start of the vas deferens, and it goes all the way up and will eventually transition into the spermatic cord. So if you've heard of a vasectomy in humans, that's where they actually sever the vas deferens. This collection of blood vessels right here is called the pampiniform plexus. And if we think about body temperature, it's relatively warm. We don't want really warm or hot blood to reach the testicle because it will kill or denature the sperm. So the pampiniform plexus is a series or a complex of blood vessels that serve to remove heat from the blood before it reaches the testicle. And after that, it's going to travel up the spermatic cord. If you guys trace, let's find your sigmoid flexure. That's probably good. You may have to hold it for a second while I practice. So what's going to happen is sperm's going to travel up the spermatic cord, and if you remember from lecture, it's going to pass behind the ischium and go through the vesicular glands. And the vesicular glands are what secretes that fructose-rich fluid that give the sperm energy and allow them to maintain that mobility. Then it's going to go to the prostate gland and the bulbourethral gland. And both of those glands serve to neutralize the acidity of urine, which is also introduced around that same time. So it's passing right behind the bladder and passing both of or all three of those accessory sex glands, and then transitioning into the penis, which this would be the root back here. This is the sigmoid flexure here. So you can see this muscle right there maintains, if it's relaxed, you can actually lengthen the penis. If it's contracted, it's going to form that S curve and pull it back up into the body. On the outside, this is called the prepuce, and this whole thing is called the sheath. And they house or protect the penis itself. So if we then try to cut backwards, we can see the glans penis, and then feel the os penis, which is a bone that we can feel within there. So the glans penis, if you flip through your book and go look at the lecture notes, it's the part that varies the most among species. So goats have a relatively simple, goats and small ruminants. Dogs and stallions have what's called a bulbous glandus, which if you flip over a couple of pages, sorry, right there. As that gets bigger, as blood reaches it, it engorges, and in dogs is what's forms the tie and lock that you see when dogs mate. So they have a bulbous glandus, but this is the glans penis here. This part sticking off the end there is the urethral process. And that's unique to small ruminants. Boars have a glans penis, if you look there, that's a corkscrew right there. So if you remember from lecture, the cervix of a sow has a corkscrew orientation. Cats have, on their glans penis, they actually have barbs. And the cool thing about cats, or the thing that's different about a cat, is a tomcat's orientation will go caudally versus cranially. So if you've ever seen cats mating, it looks like they're rear end to rear end, and that's why. It's because it's projecting caudally. So urethral process, glans penis, you feel right there, you feel a bone. And that's called the os penis. And the interesting thing about the os penis in small ruminants, or any ruminant really, is when they're fed a high concentrate diet, we can see urinary calculi, which is like crystals or formations of stones in the urine. And the urethra passes through the middle of that os penis. So think about the animal's trying to urinate and it's got urinary calculi. It gets to that part of the urethra where it narrows to go through that bone and it can't go through. So it's a problem when you have urinary calculi that migrate all the way down to this part of the urethra, because it will cause a blockage, and that's obviously very painful and hard to treat because it's inside of the penis and it's inside of that bone. So that's why urinary calculi are a problem with small ruminants. So that's it for the male. Make sure